Welcome to Tech with Kaushik. This is part 2 of our complete practice question series for the AZ-305 Microsoft Certified Solutions Architect Expert exam. Choose your answer before the timer ends. Then review the correct answer, explanation, and exam tip. Let us begin part 2. Question number 46 highlights an important distinction. We are now working with identity governance. The central scenario is as follows. A consultancy provides 10 project-specific web applications. Employees frequently transfer between projects. Each project owner must review application membership every month, and rejected or unreviewed assignments must be removable automatically. Which Microsoft service capability should be recommended? Focus on the distinction between these options. Option A, Microsoft Defender for Identity. Option B, Microsoft Intra-Permissions Management. Option C, Microsoft Intra-ID Governance Access Reviews. Option D, Microsoft Intra-ID Protection. In this case, select Option C, Microsoft Intra-ID Governance Access Reviews. The reasoning is as follows. Microsoft Intra-ID Governance supports recurring access reviews for application assignments, delegates reviews to appropriate owners, and can apply review decisions to remove stale access automatically. Now consider why the remaining options are unsuitable. A. Defender for Identity detects identity threats in hybrid environments. It does not run recurring application access certifications. B. Permissions management focuses on cloud infrastructure entitlements rather than recurring reviews of intra-application assignments. D. ID protection evaluates sign-in and user risk. It does not manage project membership reviews. The key takeaway is use Microsoft Intra-ID Governance Access Reviews when business owners must periodically certify group, application, or privileged access. Review question number 47. Carefully, consider the following scenario. An organization has many Azure SQL databases. A remediation template enables an encryption setting when a database is non-compliant. The policy must deploy that template and grant its assignment identity only the permissions needed for remediation. Complete the policy definition design. Review Statement 1. The policy effect should be the blank. Select from 1. Deploy if not exists, modify, or audit if not exists. Review Statement 2. The definition must declare the blank. Select from 2. The RBAC role definition IDs required by remediation, the future policy assignment scopes, or the assignment identity's principal ID. For Statement 1, select Deploy if not exists. Deploy if not exists is the effect that executes the remediation template. For Statement 2, select the RBAC role definition IDs required by remediation. The policy definition declares required RBAC roles. Assignment scope and identity are configured when the policy is assigned. Deploy if not exists needs an assignment identity and role definition IDs that authorize the remediation deployment. Question number 48. This is a harder question, so check every requirement carefully. A log analytics workspace ingests approximately 120 gigabytes per day into an analytics plan table used by a scheduled log alert. Every record must continue to be ingested, and the alert behavior should remain unchanged while ingestion cost is reduced. Select the resource and pricing change. Choose the correct entry for every drop-down field. For the first statement, modify the blank. The options for this statement are 1. The log analytics workspace, the analytics table, or the source web app. For the second statement, apply the blank. The options for this statement are 2. A commitment tier, the basic logs plan, or a daily ingestion cap. Statement 1 should be completed with the log analytics workspace. Commitment tiers are configured for the workspace. Statement 2 should be completed with a commitment tier. Basic logs can restrict query and alert behavior, while a daily cap would stop ingestion and violate the requirement. Exam tip. Use commitment tiers for predictable high-volume analytics ingestion. Do not use a daily cap when all data must be collected. Question number 49. Requires careful analysis. Analyze the scenario before evaluating the choices. An enterprise has 12 subscriptions shared by 3 programs. Each program owns resources in several subscriptions, and a subscription can contain resources from more than one program. Finance needs low maintenance, program-level cost monitoring. Which two components should be included? Select 2. More than one answer may be correct. Eliminate any option that fails a requirement. Consider option A, cost management budgets. Consider option B, resource tags. Consider option C, custom Azure or BAC roles. Consider option D, management groups. Consider option E, Azure boards. Select option A, cost management budgets, and option B, resource tags. Apply a consistent program tag to resources and use tag-filtered cost management views or budgets to track and alert on each program across subscription boundaries. The incorrect choices fail for the following reasons. C. Custom roles control permissions and do not classify consumption by program. D. A subscription can belong to only one management group hierarchy position, so management groups cannot separate resources from multiple programs inside shared subscriptions. E. Azure Boards tracks work items, not Azure consumption. A useful examination rule is this. Use tags for cross-cutting cost allocation when organizational units share subscriptions, then filter budgets and reports by tag. Apply precise reasoning to question number 50. We are moving to load balancing. Pay close attention to every stated constraint. A public standard load balancer distributes traffic to a virtual machine scale set. All inbound flows must transparently pass through a scalable pair of network virtual appliances before reaching the workload. The design should avoid manually maintained routes. Which Azure service should be inserted into the traffic path? Compare every choice before deciding. Next, option A, Azure Traffic Manager. Next, option B, Azure Application Gateway. Next, option C, Gateway Load Balancer. Next, option D, Azure Front Door. The appropriate choice is option C, Gateway Load Balancer. The requirement is satisfied because Gateway Load Balancer is built for transparent, highly available insertion of network virtual appliances. It can be chained to a standard load balancer frontend without requiring applications to manage the appliances. The remaining options are incorrect because A. Traffic Manager is DNS-based global routing and does not transparently insert NVAs. B. Application Gateway is an HTTP/S, reverse proxy, and WAF, not a transparent NVA chaining service. D. Front Door is a global HTTP/S, edge service and does not distribute flows through regional NVAs. Remember this distinction for the exam. Choose Gateway Load Balancer when a workload frontend must be transparently chained to scalable NVAs. Let us examine question number 51. Review the scenario carefully. A public API platform uses Azure Front Door with WAF at the edge and Azure API management in front of AP is running on AKS. Customers authenticate through an external identity provider federated with a Microsoft Intra external ID tenant. Map each security function to the service that should enforce it. The items to be placed are: the first source item is block common OWASP web exploits before traffic reaches the regional API gateway. The second source item is restrict selected AP is by caller IP address. The third source item is validate JWTs issued for the external identity tenant. The destination requirements are as follows. Destination A, Azure Front Door. Destination B, Azure API Management. The correct destination for block common OWASP web exploits before traffic reaches the regional API gateway is Azure Front Door. The correct destination for restrict selected AP is by caller IP address is Azure API Management. The correct destination for validate JWTs issued for the external identity tenant is Azure API Management. The key reason is Front Door WAF applies managed OWASP rules at the edge. API management policies can apply per API IP filtering and validate JWT claims before requests reach AKS. Keep this examination point in mind. Use WAF for edge web threat filtering and API management policies for API-specific authorization and token validation. Let us focus on question number 52. This question moves us into monitoring architecture. This scenario establishes the key requirement. A multi-tier application runs in several Azure container instances. Operations requires availability tests and end-to-end dependency telemetry with the least custom monitoring code. Which Azure Monitor capability should be selected? The relevant choices are as follows. Now examine choice A, Container Insights. Now examine choice B, Application Insights. Now examine choice C, Network Insights. Now examine choice D, Log Analytics Workspace Insights. The best answer is option B, Application Insights. This is correct because Application Insights provides availability tests, application performance monitoring, dependency tracking, and distributed tracing. Supported instrumentation or open telemetry can reduce custom development. The other choices do not satisfy the requirement because A, Container Insights focuses on container infrastructure and workload telemetry rather than synthetic application transactions. C, Network Insights monitors network resources and connectivity, not application-level transactions. D, Workspace Insights reports workspace usage and health rather than application dependencies. The key takeaway is use Application Insights for synthetic availability checks and end-to-end application transaction telemetry. Let us work through question number 53. Let us first review the situation. A regulated workload deploys app service and Azure SQL resources together. Both resources must be restricted to approved Azure regions and must be co-located in the same selected region. For each statement, select yes if the statement is true. Otherwise, select no. Review Statement 1. An initiative that restricts only the location property of resource groups is sufficient to enforce the workload requirement. The answer to Statement 1 is no. A resource group's location stores its metadata and does not force resources inside the group to use that region. Policies must evaluate the deployable resources location properties. Resource group location is metadata. Enforce allowed locations on the actual resource types. The next key item is question number 54. Focus on the following situation. Storage accounts are governed by Azure policy. Operations must be able to start an immediate compliance evaluation and create Azure Monitor log alerts for policy-related non-compliance events queried in Log Analytics. Select the mechanism for each requirement. Select the value that correctly completes each statement. The first statement reads, trigger the on-demand compliance scan by using the blank. The available choices are 1. Azure CLI, an ARM template deployment, or the storage account data plane logs. The second statement reads, route policy-related platform events by configuring diagnostic settings for the blank. The available choices are 2. The Azure Activity Log, the Log Analytics Workspace, or individual storage account resource logs. The correct value for Statement 1 is Azure CLI. The Azure CLI provides the on-demand trigger scan operation. The correct value for Statement 2 is the Azure Activity Log. The Activity Log is the subscription-level source that should be routed to Log Analytics. Exam tip. Use Policy Insights for compliance state and route the subscription activity log when Azure Monitor log alerts need platform policy events. We will now analyze question number 55. Next, we enter the topic of authorization design. Begin by examining the scenario. A company will store block blobs and SMB file shares. Storage account key authorization will be disabled. Blob access should be delegated for limited periods, while SMB users should authenticate without shared keys. Select the authorization method for each workload. Review each blank and choose the most appropriate option. Statement 1. Grant temporary blob access with the blank. Choose between 1. A user delegation SAS, a service SAS tied to a stored access policy, or an account SAS. Statement 2. Authorize SMB file share access with the blank. Choose between 2. Microsoft Intra credentials, a user delegation SAS, or a storage account key. The answer to the first statement is a user delegation SAS. User delegation SAS is the strongest SAS choice for blob data when shared key authorization is prohibited. The answer to the second statement is Microsoft Intra credentials. User delegation SAS is not used for Azure Files SMB. Identity-based SMB authentication meets the no shared key requirement. A useful examination rule is this. User delegation SAS applies to blob storage. Use identity-based authentication for SMB file shares. Let us work through question number 56. Begin by examining the scenario. Windows Server virtual machines run Azure Monitor Agent and write structured JSON files locally. The records must be sent to a custom log analytics table after reshaping fields during ingestion. Complete the collection design. Review Statement 1. The collection path should use the blank. Choose between 1. An Azure Monitor Data Collection endpoint, a linked storage account, or a virtual network service endpoint. Review Statement 2. The ingestion time transformation should be written as the blank. Choose between 2. A KQL query, an XPath query, or a WL query. Statement 1 should be completed with an Azure Monitor Data Collection endpoint. A data collection endpoint provides the Azure Monitor ingestion endpoint used by the collection configuration. Statement 2 should be completed with a KQL query. KQL is the supported language for DCR ingestion time transformations. Remember this distinction for the exam. Azure Monitor Agent Collection is governed by DCRs. Use KQL transformations to shape records before ingestion. We will now analyze question number 57. This is marked as a medium question. Consider the following scenario. A storage account already has blob versioning and blob soft delete enabled. The organization wants account-level point-in-time restore for supported blob data. Select the supported blob type and the additional prerequisite. Complete each statement by selecting the appropriate value. The first statement reads, point-in-time restore applies to the blank. Select from 1. Block blobs, append blobs, or page blobs. The second statement reads, the account must also enable the blank. Select from 2. Blob change feed, object replication, or a stored access policy. For Statement 1, select Block Blobs. Only block blobs are supported by Blob Point-in-Time Restore. For Statement 2, select Blob Change Feed. Change feed records the ordered changes required by the restore operation. Keep this examination point in mind. Blob Point-in-Time Restore requires block blobs, soft delete, versioning, and change feed. Proceed to question number 58. Consider this scenario. A manufacturer receives SQL Server research data from a partner. The data must be extracted, transformed to the manufacturer's lake schema, and loaded into data lake storage. The partner must later receive governed, read-only snapshots of selected analytical datasets. Select the Azure service for each requirement. Choose the correct entry for every drop-down field. Statement 1. Extract and transform the partner data by using the blank. The available choices are 1. Azure Synapse Pipelines, Azure Data Share, or Azure Data Box Gateway. Statement 2. Distribute controlled dataset snapshots by using the blank. The available choices are 2. Azure Data Share, Azure Synapse Pipelines, or Azure Data Box Gateway. The correct value for Statement 1 is Azure Synapse Pipelines. Synapse Pipelines provide integration and transformation. The correct value for Statement 2 is Azure Data Share. Azure Data Share is designed for controlled cross-organization dataset sharing. The key takeaway is use pipelines to move and transform data. Use Data Share to publish governed snapshots. The next item is question number 59. The focus now shifts to backup architecture. Scenario. A production subscription must protect workloads with Azure Backup. Destructive backup operations must require authorization from a security identity located in a separate Microsoft intratenant and subscription. Select the resource to deploy in each subscription. Review each blank and choose the most appropriate option. For the first statement, in the protected production subscription, create the blank. The options for this statement are 1. A recovery services vault, a resource guard, or Microsoft Azure Backup Server. For the second statement, in the security subscription, create the blank. The options for this statement are 2. A resource guard, a recovery services vault, or an Azure Site Recovery Plan. The answer to the first statement is a recovery services vault. The backup workload is protected through the vault in the production subscription. The answer to the second statement is a resource guard. The resource guard should reside in the separate administrative boundary that approves critical operations. Use resource guard and multi-user authorization to protect critical Azure backup operations from compromised vault administrators. Review question number 60. Carefully. Let us first review the situation. An internet-facing application runs in AKS clusters across 5 regions. HTTPS requests must reach the healthy region with the best network latency. Regional failure detection must be fast, and requests inside each region must be routed to Kubernetes services through an ingress implementation. Select the global and regional components. Complete each statement by selecting the appropriate value. The first statement reads, use the blank for global HTTPS routing. Choose between 1. Azure Front Door, Azure Traffic Manager, or cross-region Azure Load Balancer. The second statement reads, use the blank as the AKS ingress component. Choose between 2. Azure Application Gateway, Azure Standard Load Balancer, or Azure Basic Load Balancer. The answer to the first statement is Azure Front Door. Front Door meets latency-aware global HTTPS routing and fast health-based failover. The answer to the second statement is Azure Application Gateway. Application Gateway provides HTTPS ingress capabilities. Azure Load Balancer is Layer 4 and is not an ingress controller. Exam tip. Combine Front Door for global HTTPS routing with a regional Layer 7 ingress for AKS. Let us examine question number 61. We are moving to compute architecture. Review the scenario carefully. A Linux-hosted Java web application is accessed interactively over HTTPS. Demand varies sharply, and several instances run concurrently. Repackaging the application as a container would require substantial redevelopment. The migration team wants managed autoscaling with minimal platform administration. Which Azure Compute Service should be recommended? Review each available choice. Choice A, Azure Virtual Machine Scale Sets. Choice B, Azure App Service. Choice C, Azure Kubernetes Service. Choice D, Azure Batch. The required response is option B, Azure App Service. Here is the technical justification. Azure App Service can host Java web applications directly, supports multiple instances and autoscale, and removes VM or cluster management. It avoids the major containerization effort required by AKS. The alternatives can be eliminated because A, VM scale sets can autoscale, but require operating system and application host management. C, AKS adds cluster administration and would require the application to be containerized. D, Azure Batch is intended for scheduled or parallel batch jobs, not an interactive HTTPS web application. A useful examination rule is this. Prefer app service for supported web runtimes when autoscale and low operational effort matter more than infrastructure control. Now consider question number 62. Review the situation. A periodic pipeline lands database changes in blob storage, performs massively parallel transformations, and loads a relational enterprise warehouse. Each completed batch refreshes a managed tabular semantic model queried by thousands of reporting users. Select the warehouse and serving layer technologies. Select the value that correctly completes each statement. Statement 1. Implement the enterprise data warehouse with the blank. The options for this statement are 1. An Azure Synapse dedicated SQL pool, an Azure Synapse Apache Spark pool, or Azure Data Lake Analytics. Statement 2. Implement the managed semantic serving layer with the blank. The options for this statement are 2. Azure Analysis Services, an Azure Synapse dedicated SQL pool, or an Azure Synapse Apache Spark pool. For Statement 1, select an Azure Synapse dedicated SQL pool. The dedicated SQL pool is the warehouse engine rather than the Spark transformation runtime. For Statement 2, select Azure Analysis Services. Azure Analysis Services is the option designed to host the managed tabular semantic model. Remember this distinction for the exam. Separate the physical warehouse from the semantic model that serves business users. Note, while Power BI or Fabric are often recommended for new deployments, Azure Analysis Services remains a fully supported architecture choice for semantic modeling. The next item is question number 63. Next, we enter the topic of backup architecture. Consider this scenario. 10 on-premises Windows servers require daily file and folder backups directly to a recovery services vault. The vault storage should keep 3 synchronous copies in one region at the lowest cost. Select the server component and vault redundancy. Choose the correct entry for every drop-down field. Review Statement 1. Install the blank on each server. Select from 1. The Microsoft Azure Recovery Services Agent, the Azure Site Recovery Mobility Service, or Volume Shadow Copy Service only. Review Statement 2. Configure the vault to use the blank. Select from 2. Locally redundant storage, zone redundant storage, or geo-redundant storage. Statement 1 should be completed with a Microsoft Azure Recovery Services Agent. MARS provides the required direct file and folder backup. Statement 2 should be completed with locally redundant storage. LRS meets the 3-copy requirement at minimum cost. Keep this examination point in mind. Match vault redundancy to the stated durability scope. 3 local copies indicates LRS. Proceed to question number 64. Scenario. A document storage account must support centrally enforced version-level worm retention. Security administrators must also be able to permanently remove soft-deleted blob versions when data is discovered in an unauthorized copy location. Which 2 storage account settings should be enabled? Select 2. Choose every option that satisfies the requirement. The options are: Option A, Operational Backup with Azure Backup. Option B, Point-in-time Restore for containers. Option C, Permanent Delete for soft-deleted blobs. Option D, Blob Change Feed. Option E, Version-level immutability support. The required selections are Option C, Permanent Delete for soft-deleted blobs, and Option E, Version-level immutability support. The reasoning is as follows. Version-level immutability support enables retention or legal hold policies at blob version scope. Permanent delete permits an authorized principal to purge soft-deleted blob versions before the normal retention period expires. A. Operational backup protects recoverability, but does not provide worm enforcement or immediate purge capability. B. Point-in-time restore protects against changes and does not standardize immutable retention. D. Change feed records blob changes and is not a retention or purge control. The key takeaway is immutability prevents alteration. Permanent delete is a separate privileged capability for purging soft-deleted data. We will now analyze question number 65. The focus now shifts to API integration. Begin by examining the scenario. AKS hosts several APIs on different HTTP ports. A standard tier API management gateway will publish them externally. The backend connection must use mutual TLS, and the team wants one managed routing and certificate termination point instead of exposing every Kubernetes service separately. Which AKS component should be added? Compare the following options. Option A is an external name service. Option B is an external load balancer for every API. Option C is API management deployment into the AKS node subnet. Option D is an ingress controller. The correct answer is Option D, an ingress controller. An ingress controller provides a consolidated layer 7 endpoint for multiple Kubernetes services and can enforce TLS or mutual TLS while routing to services on their internal ports. This minimizes repeated exposure and certificate logic. Now consider why the remaining options are unsuitable. A. External name only maps a service to an external DNS name and does not provide ingress or MTLS termination. B. Separate external load balancers increase cost and administration and do not centralize layer 7 routing. C. Placing API management in a virtual network provides connectivity but does not itself create the required AKS ingress endpoint. Use an ingress controller to centralize HTTP routing and TLS policy for multiple AKS services behind an API gateway. Let us focus on question number 66. The central scenario is as follows. An Azure Synapse workspace must query an Azure Cosmos DB account without public internet routing. The connection should remain on the Microsoft backbone and require the least custom network administration. Complete the private connectivity design. For the first statement, provision the Synapse workspace with the blank. The available choices are 1. A managed virtual network, public workspace endpoints only, or Microsoft Intra authentication only. For the second statement, create the blank for the Cosmos DB connection. The available choices are 2. A managed private endpoint, a service endpoint policy, or a server-level firewall rule. The correct value for statement 1 is a managed virtual network. The managed VNet provides the required workspace side isolation. The correct value for statement 2 is a managed private endpoint. A managed private endpoint, created from Synapse and approved on Cosmos DB, prevents internet routing. Exam tip. Synapse Managed VNet plus Managed Private Endpoints is the managed pattern for private access to supported past data sources. Question number 67. This question moves us into hybrid identity. Remote employees need browser access to an on-premises Windows web application that uses Active Directory authentication. Users must not establish a VPN, and Microsoft Intra multi-factor authentication must be enforced with minimal application change. Select the cloud object and on-premises component. Select the value that correctly completes each statement. Statement 1. Publish the application in Microsoft Intra ID as the blank. Choose between 1. An enterprise application, an app registration only, or an access package. Statement 2. Install the blank on-premises. Choose between 2. The Microsoft Intra Application Proxy Connector, the on-premises data gateway, or the web application proxy role service. Statement 1 should be completed with an enterprise application. The enterprise application represents and controls access to the published app. Statement 2 should be completed with the Microsoft Intra Application Proxy Connector. The application proxy connector provides the outbound tunnel. The data gateway and web application proxy do not integrate with Intra Application Proxy in this design. A useful examination rule is this. Use Microsoft Intra Application Proxy to publish supported on-premises web apps and apply conditional access without inbound firewall exposure. Review question number 68. Carefully. Review the scenario carefully. An app service web app must reach an Azure SQL database only through private link. The web app needs regional virtual network integration for outbound traffic. An SQL name resolution must return the private endpoint address. Select the minimum network design. Complete each statement by selecting the appropriate value. Review statement 1. The virtual network requires at least a blank. The available choices are 1. 2 subnets, 1 subnet, or 3 subnets. Review statement 2. Resolve the SQL private link name by using the blank. The available choices are 2. An Azure private DNS zone, a public DNS zone, or Azure DNS private resolver only. The correct value for statement 1 is 2 subnets. Separate integration and private endpoint subnets produce the minimum supported design. The correct value for statement 2 is an Azure private DNS zone. Private DNS supplies the private link.database.windows.net mapping. A private resolver is unnecessary when Azure-hosted clients use a linked zone. Remember this distinction for the exam. Private endpoints need correct DNS, and app service VNet integration should use a dedicated subnet. Now consider question number 69. Review the situation. A retailer must incrementally ingest data from on-premises SQL Server, MySQL, and Oracle systems into data lake storage. The managed service should orchestrate connectors, schedules, and ETL transformations with minimal operations work. Which service should be recommended? Choice A, Azure Data Explorer. Choice B, Azure Data Share. Choice C, Azure Data Factory. Choice D, Azure Data Studio. The appropriate choice is option C, Azure Data Factory. The requirement is satisfied because Azure Data Factory is a managed data integration service with connectors, self-hosted integration runtime, scheduling, incremental copy patterns, and transformation orchestration for heterogeneous on-premises databases. The incorrect choices fail for the following reasons. A. Data Explorer is an analytics engine, not the general ETL orchestration service for these sources. B. Data Share distributes datasets between parties and does not build ingestion pipelines. D. Data Studio is a database administration client, not a managed ETL platform. Keep this examination point in mind. Choose Data Factory or Synapse pipelines for managed, connector-based ETL and orchestration across heterogeneous data sources. The next item is question number 70. Take extra care here because this is a hard question. Scenario: a VMware vSphere environment managed by vCenter hosts 100 virtual machines. The organization will assess and migrate the virtual machines to native Azure virtual machines through Azure Migrate with minimal deployment effort. Map each Azure Migrate resource to where it should be created. Review the available source items. Source item 1, Azure Migrate Project. Source item 2, Azure Migrate Appliance. Now review the available destinations. Target A, Azure Subscription. Target B, on-premises VMware environment. For mapping 1, pair Azure Migrate Project with Azure Subscription. For mapping 2, pair Azure Migrate Appliance with on-premises VMware environment. The key reason is the project is the Azure control plane container for discovery, assessment, and migration. The appliance is deployed in the VMware environment, so it can communicate with vCenter and collect inventory and performance data. The key takeaway is create the Azure Migrate project in Azure and deploy the Discovery appliance close to the source environment. Let us work through question number 71. Consider the following scenario. A general-purpose V2 storage account must support customer-managed regional failover and later failback. The team wants the shortest practical outage and must restore geo-replication after each role change. Arrange the 3 actions in the correct sequence. The sequence must use these items. Item 1. After failover, configure geo-redundant replication for the account. Item 2. Initiate the storage account failover. Item 3. Before failover, configure geo-redundant replication for the account. The correct sequence is as follows. The first item is before failover, configure geo-redundant replication for the account. The second item is initiate the storage account failover. The third item is after failover, configure geo-redundant replication for the account. This is correct because geo-replication must exist before customer-managed failover. Failover promotes the secondary and converts the account to local redundancy. Re-enabling geo-redundant replication establishes a new secondary and makes a later failback possible. Storage account failover requires geo-redundancy first. After promotion, re-enable geo-replication before planning failback. Question number 72. Next, we enter the topic of data durability. Consider this scenario. An application overwrites the same block blob every hour. Each day's final state must remain recoverable for 30 days after later overwrites. Protection should expire automatically after the retention period and should avoid retaining versions indefinitely. Which blob storage feature should be configured with a 30-day retention period? Review the options. Option A, blob versioning without lifecycle rules. Option B, container soft delete. Option C, blob soft delete. Option D, manually created blob snapshots. In this case, select option C, blob soft delete. Here is the technical justification. Blob soft delete preserves data when a block blob is overwritten or deleted and automatically removes protected states after the configured retention period. It meets the recovery window without indefinitely accumulating versions, which would require an additional lifecycle management policy if blob versioning were used instead. The remaining options are incorrect because A, versioning retains each version until it is explicitly deleted or removed by lifecycle management, which can consume more storage. B, container soft delete protects deleted containers, not each overwrite of an existing blob. D, manual snapshots require application or operational changes and do not provide the lowest administration retention behavior. Exam tip: use blob soft delete for a bounded overwrite and deletion recovery window. Use versioning when durable per-write version history is required. Now consider question number 73. A company needs a managed platform for stateless containers. It must auto-scale application replicas, avoid Kubernetes node administration, support zone-resilient deployment where available, and use a central private image repository. Select the runtime and image service. Review each blank and choose the most appropriate option. The first statement reads, run the applications on the blank. Select from 1. Azure Container Apps, Azure Kubernetes Service, or Azure Container Instances. The second statement reads, store and manage container images in the blank. Select from 2. Azure Container Registry, Azure Container Apps, or Azure Service Fabric. The answer to the first statement is Azure Container Apps. Container Apps minimizes orchestration administration while providing autoscale. The answer to the second statement is Azure Container Registry. Container Registry is the dedicated image registry and lifecycle service. A useful examination rule is this. Separate the container runtime from the registry. Use container apps when Kubernetes control is unnecessary. Proceed to question number 74. Review the situation. A Cosmos DB for NoSQL container has analytical store enabled. Data scientists must process changes with a runtime inside an Azure Synapse workspace and write curated results to a dedicated warehouse. The design should query analytical store directly and minimize data movement. Which Synapse pool should perform the processing? Available choices. Choice A, Serverless SQL pool. Choice B, Data Explorer pool. Choice C, Apache Spark pool. Choice D, Dedicated SQL pool. The best answer is option C, Apache Spark pool. The reasoning is as follows. An Apache Spark pool can use Azure Synapse Link to read the Cosmos DB analytical store directly for near real-time processing and then write transformed results to the warehouse without a separate operational data copy pipeline. The other choices do not satisfy the requirement because A, Serverless SQL can query analytical data but is not the requested general processing runtime for the transformation workflow. B, Data Explorer is optimized for log and telemetry analytics and is not the direct Synapse Link processing choice here. D, the dedicated SQL pool is the warehouse destination, not the runtime selected to process the analytical store with minimal movement. Remember this distinction for the exam. With Cosmos DB Analytical Store, use Synapse Link and choose Spark when the workload requires scalable transformation before warehouse loading. The next item is question number 75. This is a hard-level item, so avoid choosing too quickly. Scenario. Virtual machines are distributed across subscriptions in 5 separate Microsoft Intra tenants. A central operations tenant must collect Windows security events into one log analytics workspace and define event selection through data collection rules. Select the cross-tenant management and agent components. Choose the correct entry for every drop-down field. For the first statement, delegate cross-tenant monitoring access by using the blank. The options for this statement are 1. Azure Lighthouse, Azure Event Grid, or Microsoft Purview. For the second statement, collect events under DCR control by using the blank. The options for this statement are 2. Azure Monitor Agent, Log Analytics Agent, or Azure Connected Machine Agent. For statement 1, select Azure Lighthouse. Lighthouse provides the required cross-tenant control plane. For statement 2, select Azure Monitor Agent. Azure Monitor Agent is the DCR-based replacement for the legacy Log Analytics Agent. Azure Connected Machine onboards non-Azure servers, but is not the event collection agent. Keep this examination point in mind. Use Azure Lighthouse for cross-tenant operations and Azure Monitor Agent when DCR-based collection is required. Let us examine question number 76. Let us first review the situation. A managed relational workload needs several readable secondary replicas in one region. Read intent connections must be distributed across the available high-availability replicas without the team deploying a separate load balancer. Select the Azure SQL product and tier. Review each blank and choose the most appropriate option. Statement 1. Use the blank. Choose between 1. A single Azure SQL database, an Azure SQL Database Elastic Pool, or Azure SQL Managed Instance. Statement 2. Choose the blank service tier. Choose between 2. Hyperscale, Business Critical, or Premium. For Statement 1, select a single Azure SQL database. A single database is the unit that supports configurable hyperscale replicas. For Statement 2, select Hyperscale. Hyperscale supports multiple high-availability replicas. Premium and managed instance business critical generally provide a single built-in readable secondary for this scenario. The key takeaway is use Hyperscale when one database needs configurable multiple RED replicas. Named replicas use distinct endpoints for isolated workloads. Now consider question number 77. This question moves us into private connectivity. OneLog Analytics Workspace receives virtual machine logs from 3 virtual networks. 2 VNets are peered and share private DNS connectivity. The third is isolated. All ingestion and query traffic must use Azure Monitor Private Link with the fewest objects. Select the minimum design. Select the value that correctly completes each statement. For the first statement, create the blank Azure Monitor Private Link Scope object. The options for this statement are 1, 2, or 3. For the second statement, create the blank private endpoints. The options for this statement are 2, 1, or 3. The answer to the first statement is 1. A single AMPLS can scope the workspace for all participating networks. The answer to the second statement is 2. Network reachability allows one endpoint for the peered pair and requires a second endpoint for the isolated VNet. Count AMPLS objects by monitored resource scope and private endpoints by isolated network reachability domains. Proceed to question number 78. Consider this scenario. Azure RBAC controls access to data in many storage accounts. Authorization decisions must evaluate resource attributes such as blob index tags within role assignment conditions. Select the authorization model and supported data type. Complete each statement by selecting the appropriate value. The first statement reads, implement the conditions by using the blank. The available choices are 1. Azure Attribute-Based Access Control, ABAC, Access Control Lists, or Shared Access Signatures. The second statement reads, apply the tag-based data conditions to the blank. The available choices are 2. Blobs, Azure File Shares, or Tables. Statement 1 should be completed with Azure Attribute-Based Access Control, ABAC. ABAC is the Azure RBAC condition model. Statement 2 should be completed with blobs. Blob data actions support the relevant resource attributes. Azure Files and Tables do not provide the same blob tag condition model. Exam tip. Use Azure ABAC when RBAC decisions must include supported resource attributes such as blob index tags. Question number 79. We are moving to server migration. Review the situation. A physical server runs SQL Server 2022 with a 30 terabytes database and a custom compliance application. The application must remain on the same operating system instance as SQL Server after migration. The team wants the lowest effort lift and shift path. Select the Azure Target and Migration Service. Review each blank and choose the most appropriate option. Review Statement 1. Migrate the workload to the blank. Select from 1. SQL Server on Azure Virtual Machines, Azure SQL Managed Instance, or Azure SQL Database. Review Statement 2. Perform the server migration by using the blank. Select from 2. Azure Migrate, Azure Database Migration Service, or the Azure SQL Migration Extension. The correct value for Statement 1 is SQL Server on Azure Virtual Machines. Past database targets cannot host the custom application on the same server. The correct value for Statement 2 is Azure Migrate. Azure Migrate moves the complete server. Database-only migration tools would not migrate the co-locate application. A useful examination rule is this. Choose a VM rehost when application and database must remain co-locate on the same OS instance. Review question number 80. Carefully. Let us first review the situation. A SaaS team needs a managed Azure SQL database with synchronous local replicas distributed across availability zones. A zone failure must not lose committed transactions. SQL Server instance compatibility is unnecessary, and costs should be minimized. Which deployment should be selected? Now examine the possible answers. Choice A. Azure SQL Database Basic. Choice B, Zone Redundant Azure SQL Database Business Critical. Choice C, Azure SQL Database Standard. Choice D, Zone Redundant Azure SQL Managed Instance Business Critical. The correct answer is option B, Zone Redundant Azure SQL Database Business Critical. Azure SQL Database Business Critical uses synchronous replicas and supports zone redundant placement. It meets the no data loss zone failure requirement without the extra cost of managed instance. The alternatives can be eliminated because A, Basic does not support zone redundancy or the required replica architecture. C, Standard does not support zone redundancy natively. D, Managed Instance Business Critical can satisfy the requirement, but is more expensive and adds unneeded instance-level compatibility. Remember this distinction for the exam. Use Zone Redundant Business Critical when vCore-based Azure SQL database needs synchronous multi-zone replicas. Let us examine question number 81. Begin by examining the scenario. A ticketing platform uses a single Azure SQL database under the DTU purchasing model. The database must continue operating through an availability zone failure, and replica failover must be synchronous. The design should use the lowest DTU tier that supports zone redundancy. Which deployment option should the architect recommend? Choose from the following options. Option A is Azure SQL Database Hyperscale. Option B is Azure SQL Database Premium. Option C is Azure SQL Database Basic. Option D is Azure SQL Database Business Critical. The required response is option B, Azure SQL Database Premium. The requirement is satisfied because Premium supports zone-redundant replicas with synchronous data replication and is the applicable DTU tier that satisfies the stated availability requirement. A, Hyperscale is a vCore-based architecture and is unnecessary for the stated DTU requirement. C, Basic does not provide the required zone-redundant high-availability architecture. D, Business Critical is a vCore service tier, not the requested DTU purchasing model. Keep this examination point in mind. Use Premium for DTU-based zone redundancy. Use Business Critical when the design is explicitly vCore-based. Evaluate question number 82. Against every requirement. Identify the decisive requirement in this scenario. A manufacturing portal stores operational data in a single Azure SQL database purchased with DTUs. A zone outage must not interrupt database availability, and automatic replica failover must have zero committed data loss. Cost must be minimized within the DTU model. Which option meets the requirements? Evaluate each option against the stated requirement. Consider option A, Azure SQL Managed Instance Business Critical. Consider option B, Azure SQL Database Standard. Consider option C, Azure SQL Database Premium. Consider option D, Azure SQL Database Serverless. In this case, select option C, Azure SQL Database Premium. The key reason is Premium is the DTU service tier that can be configured for zone redundancy and synchronous high availability. Now consider why the remaining options are unsuitable. A, Managed Instance adds instance-level compatibility and uses the vCore model, which is not required. B, Standard does not provide the required zone-redundant architecture in the stated DTU design. D, Serverless is a compute option in the vCore model and does not match the requested DTU design. The key takeaway is first identify the purchasing model, then select the lowest tier that meets zone redundancy requirements. Now consider question number 83. Consider this scenario. A compliance team needs a scheduled monthly inventory of resource creation deployments across an Azure subscription. Activity log records will be routed to a central workspace and queried over a 30-day period. Which service should be used to query and build the report? The options are option A, Azure Monitor Metrics. Option B, Azure Arc. Option C, Log Analytics. Option D, Azure Monitor Action Groups. The appropriate choice is option C, Log Analytics. This is correct because log analytics stores routed activity log records and supports KQL queries that can identify deployment operations over a selected time range. The incorrect choices fail for the following reasons. A. Metrics contain numeric time series data, not the complete deployment audit trail. B. Azure Arc extends Azure management to external resources, but is not a deployment reporting store. D. Action groups deliver alert notifications and do not provide historical reporting. Use activity log for control plane events and log analytics when centralized querying or scheduled reporting is required. Question number 84. Scenario. A university wants a monthly report listing all ARM deployments that created resources in its research subscription. The organization already exports the subscription activity log to a workspace. Which component should generate the queryable report? Review the options. Choice A. Azure Analysis Services. Choice B. Azure Monitor Action Groups. Choice C. Log Analytics. Choice D. Azure Monitor Metrics. The best answer is option C, Log Analytics. Here is the technical justification. Log Analytics can query exported activity log records by operation, status, caller, and time range. The remaining options are incorrect because A. Analysis Services hosts semantic models and is not the native audit log query service. B. Action groups invoke notifications or automation after alerts. D. Metrics do not provide the complete resource deployment event history. Exam tip. Control plane deployment reporting is based on activity log data, typically queried in log analytics. The next item is question number 85. A retailer must issue a recurring report of every successful Azure Resource Manager deployment performed during the previous calendar month. Subscription activity log data is retained in a log analytics workspace. Which service should the reporting solution use? Option A, Application Insights. Option B, Azure Advisor. Option C, Log Analytics. Option D, Azure Analysis Services. The required response is option C, Log Analytics. The reasoning is as follows. Log Analytics supports KQL analysis and scheduled reporting over retained activity log records. The other choices do not satisfy the requirement because A. Application Insights focuses on application telemetry and distributed tracing. B. Advisor provides optimization recommendations rather than an audit history. D. Analysis Services is a BI semantic model service and is not the control plane log store. A useful examination rule is this. Route activity log data to log analytics when retention and recurring KQL-based reports are needed. We will now analyze question number 86. The focus now shifts to messaging architecture. Consider the following scenario. A logistics platform separates order capture, invoicing, stock allocation, and dispatch into independent Azure services. The services must exchange durable XML business messages asynchronously and tolerate temporary receiver outages. Which service should the architect recommend? Choose from the following options. Choice A, Azure Traffic Manager. Choice B, Azure Service Bus. Choice C, Azure Notification Hubs. Choice D, Azure Service Fabric. The correct answer is option B, Azure Service Bus. Azure Service Bus provides durable brokered queues and topics for asynchronous application-to-application messages, regardless of whether the payload is XML, JSON, or binary. The alternatives can be eliminated because A. Traffic Manager performs DNS-based endpoint routing. C. Notification Hubs sends mobile push notifications, not transactional service messages. D. Service Fabric hosts distributed applications, but is not the managed message broker requested. Remember this distinction for the exam. Choose Service Bus for durable enterprise commands and messages. Payload format does not determine the broker. Proceed to question number 87. Review the situation. A governance group exports subscription-level activity log events to a workspace. It must publish a monthly list of newly deployed ARM resources and retain the query history. Which Azure service should the group use for the analysis? Available choices. Choice A, Azure Arc. Choice B, Azure Monitor Action Groups. Choice C, Azure Analysis Services. Choice D, Log analytics. The best answer is option D, log analytics. The requirement is satisfied because log analytics provides retained log storage and KQL queries for A, RM deployment events exported from the activity log. A. Azure Arc is a hybrid and multi-cloud management plane. B. Action groups execute notification actions for alerts. C. Analysis services provides tabular semantic models rather than Azure control plane audit collection. Keep this examination point in mind. Activity log is the source. Log analytics is the query and retention destination. Let us work through question number 88. The focus now shifts to authentication design. Review the scenario carefully. A company publishes an internet-facing app service application. Employees use Microsoft Intra-joined, Intune-compliant Windows devices. The design must provide intra-single sign-on and block access from unmanaged devices. Complete the design recommendations. For the first statement, configure the blank to establish Microsoft Intra authentication for the web application. The available choices are 1. An application registration, a managed identity, or application proxy. For the second statement, configure the blank to require a compliant or Microsoft Intra-joined corporate device. The available choices are 2. A conditional access policy, Azure policy, or an administrative unit. The answer to the first statement is an application registration. An application registration represents the application in Microsoft Intra ID and supports its authentication flow. The answer to the second statement is a conditional access policy. Conditional access can evaluate device identity and compliance before granting access to the application. The key takeaway is seamless sign-in also depends on browser and device token behavior. An application registration by itself does not guarantee a zero-prompt experience in every client. Proceed to question number 89. Review the situation. An enterprise is designing governance for hundreds of Azure subscriptions. Policy assignments must be applied at hierarchy levels that can contain multiple resources. At which 3 scopes can Azure policy assignments be created? Select 3. Identify all valid responses. Review the options. Option A, individual compute resources. Option B, resource groups. Option C, Microsoft Intra administrative units. Option D, management groups. Option E, subscriptions. Option F, Microsoft Intra tenants. The choices that satisfy the requirement are Option B, resource groups, Option D, management groups, and Option E, subscriptions. The key reason is Azure policy assignments can target management groups, subscriptions, and resource groups, with effects inherited by child resources. Now consider why the remaining options are unsuitable. A. An individual resource can be an assignment scope in some APIs, but the source asks for the 3 standard hierarchy scopes used for broad governance. C. Administrative units scope Microsoft Intra administration, not Azure Resource Manager policy. F. A Microsoft Intra tenant is not an Azure policy assignment scope. Its root management group is used instead. Assign policy high in the management group hierarchy when many subscriptions need the same controls. Question number 90 highlights an important distinction. We are moving to storage performance. This scenario establishes the key requirement. A media ingestion service stores immutable objects that are read and rewritten frequently during processing. The storage layer must provide premium blob performance, very low latency, and a 1-year time-based immutability policy. Complete the storage recommendation. Statement 1. Use the blank account type. Choose between premium blob storage, standard storage v2, or premium file storage. Statement 2. Store the objects into the blank service. Choose between blob, file, or table. The correct value for Statement 1 is premium blob storage. Premium blob storage is optimized for high transaction rates and low, consistent blob latency. The correct value for Statement 2 is blob. Blob storage supports time-based immutability policies for write-once-read-many protection. Exam tip. The source uses legacy account type labels and a visual answer area. Verify regional feature support and current naming for premium blob accounts. Let us work through question number 91. Consider the following scenario. A streaming company will serve internet-accessible video objects ranging from 80 megabytes to 10 gigabytes. The application authenticates clients with certificates before issuing access, and storage cost must remain low while reads are optimized. Which storage service should hold the video objects? Now examine the possible answers. Option A is Azure SQL Database. Option B is Azure Files. Option C is Azure Blob Storage. Option D is Azure Data Lake Storage Generation 2. In this case, select Option C, Azure Blob Storage. This is correct because Azure Blob Storage is optimized for large unstructured objects, supports tiering and high-throughput HTTP access, and is generally more cost-effective than file or relational services for video content. The incorrect choices fail for the following reasons. A. SQL database is unsuitable and expensive for multi-gigabyte media objects. B. Azure Files provides SMB/NFS shares and is not the lowest cost object-serving choice. D. Data Lake Storage Generation 2 adds hierarchical namespace features that are not required for simple media delivery. A useful examination rule is this. Use blob storage for internet-delivered unstructured objects. Add data lake features only when hierarchical analytics semantics are required. You have completed part 2 of the AZ-305 practice series. Continue your preparation by opening the complete playlist and watching the remaining parts in sequence. Please like this video, subscribe to Tech with Kaushik, and enable notifications for more certification exam preparation content. Share your score, questions, or feedback in the comments. Thank you for watching. See you in the next part.